Hi there, my name is Alan Hong, Strategic Marketing Manager at Terasic Technologies. Today, I will be introducing Terasic's proprietary System Builder software, showing you how you can get started with your design easily and conveniently with just a few clicks. As FPGA designers, beginners as well as experts may know, pin assignment naming on an FPGA can be quite a hassle. A simple wrong name or conflict can add on to the frustration of long compile times. That's why Terasic has created a new convenient Windows-based GUI platform to help designers get started without the need for dealing with long datasheets and manually assigning each and every pin, a practice that would probably lead to many careless mistakes. What the System Builder allows you to do is to quickly generate pin assignments for DE4 built-in components, as well as a vast selection of supported daughter cards. But that's not it. The software also generates I/O bank power management logic, HTML documentation for managers, and it even supports multi-FPGA designs. So let's get started. As you can see here, I have a DE4 board attached to my PC, ready to begin on a new design. So now let's open up our DE4 System Builder software, which opens up to a very user-friendly display. On the top right-hand side, we can see our DE4 230, which we have selected, and we can also select our other one, DE4 530, depending on the size of our FPGA. We can specify a project name. On the left-hand side, we can see a picture of our DE4 board. On the right-hand side, we see a list of our onboard components, such as clock, slide switch, LEDs, 7-seg displays, so on and so forth. And you can notice that as we click on these onboard components, on the left, we can see that they're actually highlighted to make it very easy to understand which components we're actually using. And one of the best benefits of our System Builder software is that you can actually specify the programmable PLLs without having to actually go into Quartus. Over here we have 3 programmable PLLs. You can specify a range from 62.5 MHz up to 625 MHz, or you can even disable them in case you want to use fewer PLLs. Down on the lower left-hand side, we can see that the System Builder supports Terasic's daughter boards that connect onto the general purpose input-output pins. If you pull down the menu, you can see that you can select it as GPIO default, high-speed ADA daughter card, D5M camera, or 4.3-inch LCD touch module. On the right side of the window, you can see Altair's high-speed mezzanine connector interface is also supported. Here, Terasic has provided a great selection of over 15 daughter cards. One of the major benefits of our daughter board support is that you can actually specify meaningful prefixes to your pin names. The System Builder will then automatically assign your given name to respective pins. So for instance, if I were to manually solder a fan onto my GPIO pins, I could specify a fan underscore. And the System Builder would help me rename the generic pin name GPIO to fan underscore GPIO. When dealing with so many similar names, you can quickly and easily differentiate them with this feature. When everything is done, you can go to the bottom left-hand side and click on Save Setting. Now you can specify a name, such as Test, and save it. And the next time, you can go down again to Load Setting and click on the same Test configuration. Or you can even click on Default Setting. After all this is done, you can click on Generate to generate your project file and click on Save. Now we'll run through a quick example by building our very own video system using our DE4. As you can see, our DE4 is mounted with various data cards to build our video system. First, we have our CMOS sensor, which is 5 megapixels and connected through the GPIO pins, outputs in Bayer pattern format. For memory, we have our DDR2 memory, which is 1 gigabyte in size, and it operates at 800 megahertz. For output, we have our DVI, transmitter/receiver, which is designed for developers to access high quality and high resolution video signals that support UXGA resolutions, and is flexible due to its support for having both transmitter and a receiver on the same card. This is then outputted to our external monitor. Lastly, we have our fan, which keeps our STATIX4 device cool during operation. Now let's jump to our system builder portion. Let's get started by choosing our FPGA and naming our project. In this case, I will be using Altera's STATIX4 FPGA with 230,000 logic elements, one of Altera's high-speed, low-power FPGAs. I will name this project DE4 _ video. We can now select the onboard components. I will select a clock, LEDs, buttons, fan control, DDR2 memory, slide switches, 7-seg display, and a set of dip switches. On our external headers for GPIO, I will select a D5M 5 megapixel camera. For HSMC, I will select a DVI transmitter/receiver HSMC data card for high definition output. I can now click on Generate and save to the target folder. And we can click OK. Now let's navigate to our folder. Here you will see that we have generated 6 different files. The first one is our HTML file, which we will open right now. It gives us a broad view of our selected components without actually having to open Quartus. If we click on a link, we can see the pin assignment in I/O standard. The second file is our Quartus project file. The third file is our Quartus configuration file. The fourth is our timing constraints file. The fifth is our top module Verilog file. And the last one is our PLL Verilog file, which we will not use in this example. I will now open up Quartus to view our project. So as you can see from our top module, all of our selected components have already been declared, as well as our port declarations, our inputs and outputs. Now I can open up our assignments editor window. And as you can see, all of our pins have been assigned to their respective locations. We can also open our configuration file. And we can see that all of our configuration has already been assigned. And next we can see our constraints file. Which has also been configured for us. All of this leads is for the designer to start directly coding with the structural portion of the project, without having to deal with the complication of tedious details. So as you have hopefully seen from this demonstration today, Terasic's System Builder is a fast and convenient way to get you started with your design as fast as possible. With just a few clicks, you can automate pin assignments, PLLs, and other configurations, letting you get right into the designing portion of the project immediately. Thank you for watching.